calculator to do some of these problems. So the things get the formulas get a little bit more complicated and long at this point, so I'm just not bothered with how it gets worked out by hand. I'm just going to go straight to the calculator with these things. And so in 22, it looks like you look at 2 proportion tests and 2 sample t-tests. But this particular one is a proportion test. It works about the same with the t-test. But I'm going to get through a couple of things. It's a prospective study because we kind of put some things on it. Okay, not this part. First of all, I'm going to throw out immediately that one and that one because you can see the null hypothesis is not equal 0, which it has to be. So I guess if we look at the question, you can see it is kind of suggesting the idea that your attitude, if the parents had an attitude towards smoking, would it affect if they become a smoker? It doesn't say if one makes it better. I'm just saying, do they have evidence that the attitude influences their decisions about smoking, not do they get better or worse? So all I'm really making the claim is that they're different. So not that, would it be that P1's bigger than P2? In this particular case, that's not what we're asking. We're just saying if they're different, so we click C. It all depends on the context of the question here, right? Right. Yeah, all our assumptions come through. Okay, here's what we're interested in. So, in our calculator, we'll still live in under We'll still live in under stat. We're still going under tests. And look, these are actually labeled pretty good, right? When I have to do a t-test with 2 samples, that's t-test. T's are always the mean, right? So we use z's for proportions and t's for mean, right? So this z-test, we're never going to use. 2 sample z-test, we're never going to use. Only if it's a 2 proportion z-test. Hold on. Okay, I'm back. So we have a 2 proportion z-test, so it does, again, just the thing it looks like here. 2 proportion z-test looks like number 6. No, I've gone ahead and put everything in here already, but it told you which one to be P1, which one to be P2. So P1 is the portion of students who disapproved of smoking, so I'm just right up here, and it says, found that among the 283, 47 became smokers, so there we go, 47 became smokers. It's 283. It just looks similar. And among the 50 who were lenient, 13 became smokers, so that's going to be 13 out of 50. It's not equal to, so I calculate, and I just pull everything out of here. There's my z-score, that's my test statistic, and there's my p-value. So just get through all this here so I can show you the rest of the question. P-value, what is it, 3 decimals, so is that 0.111. So it's 10%, so 11% is higher than that, so I'm going to fail to reject the null hypothesis, so there is not sufficient evidence. Alright, maybe I should mention this, right? This one right here where you do not reject and there is sufficient evidence, and this reject and there is not sufficient evidence are never going to go together. So A and C are eliminated before you even have done anything. You already know that these can't be right, they're mixed up. Okay. What does p-value mean? Well, p-value means if the null hypothesis was true, then there is a 11% chance of this sample, which we just say is not unlikely enough. So the null hypothesis is if there is no difference in the proportions, right? That's what we said. They're equal to, the difference is 0, so they're the same. So, all I got to actually look at is this first line, right? Okay, but if there is no difference in proportions, there is about an 11% chance of seeing it observed. Okay, yes. If the conclusion is actually wrong, I guess I'm going to look over here on page 561, And that's if I failed to reject H null, but it actually was false, then I'm looking at a type 2 error. There's a little chart there in your book. It's 561. That's all I ever look at. Good. Okay. So now they want a 90% confidence interval, and we should have the same conclusion. But again, it's actually pretty user-friendly when you actually get into here. So what? I got to have a confidence interval for 2 proportions? There you go. I had 1 proportion Z interval. Now I'm doing 2 proportion Z interval. Put in the same stuff. And look, they already did it for me. All I got to do is change my confidence level to 90. And there we go. Negative 0.20 to 0.01. Like I said, all the figuring and formulas just get so long, you really just want to use a calculator. All right. So I guess what we're saying is, looking at this confidence interval is somewhere between negative 20% and positive 1%. The idea is that 0 is a possibility. So there is a possibility within this confidence interval that there was no difference. So, or 90% confident that the teens who differs from the proportion are lenient by an amount that is contained in the interval. Right? Because 0, which that was our assumption. Oh my gosh. Okay, so there's what does 90, okay, of all the, so when you talk about confidence interval, right, now, what does it mean? It means we took all those different intervals, right, that 90% of them were contain the actual difference. So of all random samples from this population, 90% will produce intervals, right, that contain the true proportion difference. Cool. So the other ones they have are with like t-tests, and they were almost the same in most cases, I guess except for this one other case. And I think just for editing purposes, I'm going to cut this one here and make the other one as a separate upload. So there'll be 2 links in this one. This one's the first one for chapter 22. I have a chapter 23 one I'll make in a second.